Hi there, and welcome back to VCE Master Academy. Last time we met the unit circle and radians. Today we are going to make it even more powerful by learning the exact values of sine, cosine, and tangent, and a lovely trick called symmetry that lets us find them for lots of angles. Don't worry if this looks hard, we'll make it simple, step by step. First, exact values. For a few special angles, sine, cosine, and tangent give us neat, exact answers. No calculator needed. The special angles are 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Or in radians, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Here is the little table to remember. Sine goes 0, 1/2, root 2 over 2, root 3 over 2, 1. Cosine is the same list backwards. 1, root 3 over 2, root 2 over 2, 1/2, 0. And tangent is sine divided by cosine, giving 0, 1 over root 3, 1, root 3, and undefined at 90 degrees. The easiest way to remember these is with two special triangles. The first is the 45, 45, 90 triangle. Two equal sides of length 1 and a longest side of root 2. The second is the 30, 60, 90 triangle, sides of 1, root 3, and 2. From these two triangles, you can read off every exact value. Keep them handy, they are your cheat sheet. Now the magic part, symmetry. The unit circle is beautifully symmetric, so once you know the values in the first quadrant, you know them everywhere. The memory trick is ASTC. Think all stations to central, starting from the first quadrant and going anti-clockwise. In the first quadrant, all three are positive. In the second, only sine is positive. In the third, only tangent is positive. In the fourth, only cosine is positive. To find a value, ask two questions. Which quadrant is the angle in, and what is its related first quadrant angle? For an angle pi minus theta, you are in the second quadrant. For pi plus theta, the third. For 2 pi minus theta, the fourth. The size of the value matches the first quadrant angle. ASTC tells you the sign. And for a negative angle, just flip. Sine of minus theta is minus sine theta. Cosine of minus theta stays cosine theta. And tangent of minus theta is minus tangent theta. Here is the circle with the four quadrants labelled A, S, T, C, so you can see exactly where each ratio stays positive. Example 1, nice and gentle, just reading the table. Sine of pi over 6 is 1/2. Cosine of pi over 3 is 1/2. And tangent of pi over 4 is 1, straight from the special triangles. Example 2, medium, using symmetry. Find sine of 2 pi over 3. 2 pi over 3 is pi minus pi over 3, so it is in the second quadrant, where sine is positive. Its related angle is pi over 3, and sine of pi over 3 is root 3 over 2. So sine of 2 pi over 3 is root 3 over 2. Next, cosine of 5 pi over 6. That is pi minus pi over 6, second quadrant, where cosine is negative. Related angle pi over 6, cosine is root 3 over 2. So with the negative sign, cosine of 5 pi over 6 is minus root 3 over 2. And tangent of 3 pi over 4. Pi minus pi over 4, second quadrant, tangent is negative. Related angle pi over 4 gives 1, so it is minus 1. Here it is on the circle. 2 pi over 3 is just the mirror image of pi over 3, reflected across the vertical axis. Same height, so the same sine value, but flipped to the left. That is symmetry doing the work for us. Example 3, an ATAR style one, third and fourth quadrants and a negative angle. Find sine of 5 pi over 3. 5 pi over 3 is 2 pi minus pi over 3, so it is in the fourth quadrant where sine is negative. Related angle pi over 3, sine is root 3 over 2, so sine of 5 pi over 3 is minus root 3 over 2. Now tangent of 7 pi over 6. 7 pi over 6 is pi plus pi over 6, third quadrant, where tangent is positive. Related angle pi over 6, tangent is 1 over root 3. So tangent of 7 pi over 6 is 1 over root 3, which we can also write as root 3 over 3. Where does this show up in real life? Think of a ramp. A ramp rises at an angle of 30 degrees and it is 4 meters long. How high does it reach? The height is 4 times sine of 30 degrees. Sine of 30 degrees is exactly 1/2. So the height is 4 times 1/2, which is 2 meters. No calculator needed, thanks to exact values. Quick summary. For the special angles 0, pi over 6, pi over 4, pi over 3, and pi over 2, sine, cosine, and tangent have exact values. Remember them with the two special triangles. Use ASTC to get the sign in each quadrant. Match the size to the first quadrant related angle. Pi minus theta for the second quadrant. Pi plus theta for the third, 2 pi minus theta for the fourth. And for negative angles, sine and tangent flip sine while cosine stays the same. Now it is your turn. Pause the video and try these 5. 1. Write the exact value of cosine of pi over 6. 2. Find the exact value of sine of 3 pi over 4. 3. Find the exact value of tangent of 2 pi over 3. 4. Find the exact value of cosine of 4 pi over 3. 5. Find the exact value of sine of minus pi over 6. Ready? Let us check them together. Question 1. Cosine of pi over 6 comes straight from the table. It is root 3 over 2. Question 2. Sine of 3 pi over 4. 3 pi over 4 is pi minus pi over 4. Second quadrant, sine positive, related angle pi over 4. So it is root 2 over 2. Question 3. Tangent of 2 pi over 3. That is pi minus pi over 3. Second quadrant, tangent negative. Related angle pi over 3 gives root 3, so it is minus root 3. Question 4. Cosine of 4 pi over 3. 4 pi over 3 is pi plus pi over 3. Third quadrant, cosine negative. Related angle pi over 3 gives 1/2, so it is minus 1/2. Question 5. Sine of minus pi over 6. Negative angle, so sine flips to minus, and sine of pi over 6 is 1/2, giving minus 1/2. Fantastic work! You now know the exact values and can use symmetry to find them anywhere on the circle. Remember, you are mastering VCE Maths, one concept at a time. I will see you in the next lesson at VCE Master Academy.